take a look at worksheet number 3, question number 2, which is part of our homework for last night. It says a 1,200 kilogram car traveling traveling north at 20 meters per second collides with a 1,400 kilogram car traveling south at 22 meters per second. They collide and entangle. When they entangle, it means they stick together and head off as one object. That was the case for questions 1, 2, and 3, and that's what made those questions similar to one another. What's the resulting velocity of the wreckage or of both of these objects combined? I'm going to take out the red pen and circle north and south to remind me to include negatives when necessary. And now I'm going to write down some givens. Let's make this one number 1. Let's make this one number 2. You know what's not a bad idea? Just as a matter of habit, it might not be a bad idea to make the light object number 1 and the heavy object number 2. Does that make sense? Okay, that way, if we get used to always having one object as number 1, we're less likely to get mixed up between the objects. So that's what we've got here. The light object is number 1, the heavy object is number 2. M1 is 1,200 kilograms, and M2 is 1,400 kilograms. You don't have to name them that way. Okay, that's just the way that I've named them and the way that I typically will name them. Now, we've got a velocity here that's 20 meters per second. Is it 20 meters per second? Should it be positive? Emma, should that be positive or should that be negative? Positive, good, because it's to the north, right? That velocity, is it V1 or is it V2, Bernardo? Yes, it's V1. Is it V1I or is it V1F? V1I or V1F? V1I. Yeah, it's V1I. It's the initial velocity of object number 1. Now, we also have another velocity here that is 22.0 meters per second. Emily, is that negative or positive? Negative. It's negative because it's good? Negative because it's south. Mason, is that V1 or is that V2? V2. Sydney, is that V2I or V2F? V2 initial, 22 meters per second, or V2 final? Good, V2 initial. And we're looking for in this question the final velocity of the wreckage. It's the combined velocity, so we're just going to call it VF. Now, you learned on Tuesday that you could analyze this as an impulse question. If you did that, you'd have to pick one object to analyze. But I'm telling you that most times you have a collision, the place to start is with conservation of momentum. Analyze the whole system together using conservation of momentum. And if something happens that doesn't work for you, well, maybe then try impulse as a second option. But try this first. PI is equal to PF. How many objects do we have before this collision takes place, Ed? Good. We're going to say M1 V1I plus M2 V2I because there's 2 objects. Or how many objects do we have after this collision takes place? Good. So we're going to call it M total times VF. Let's sub in our numbers here now. 1,200 kilograms times 20. M2 is 1,400 times negative 22. The total mass is 2,600 times VF. So what I want you to do is get this number, and then combine them by adding or subtracting, I guess, because it's negative 22. Divide by 2,600. And when you do that, you should find that VF works out to be a negative 2.62 meters per second. Negative 2.62, we could say 2.62 to the south. What you don't want to say is negative 2.62 to the south. Is that okay? Does that make sense, guys? Questions 1, 2, and 3 are all similar to this in that 2 objects become 1. M1 V1I plus M2 V2I equals M total times VF. Not all questions are like that. Question 4 is not like that. But the first 3 questions are. All real similar to one another, different contexts, but similar in nature, and similar in nature to the example question that we did on Tuesday. All right, if those are good, let's take a look at another example question. This is example number 2, which is a lot more like question number 4 and 5 on that worksheet. This one says a 0.0060 kilogram ball moving at 3 to the north collides with another ball that's going to the south. Now this first ball moves at 1 meters per second to the south after the collision. What's the velocity of the second? It says second car. Should say second ball after the collision. I'm going to circle north, south, south, so I don't forget that. What did I say? We should probably make, or at least it's not a bad habit to get into, to make the lighter object, object 1. They're both the same this time, right? So it doesn't really matter. I'll just call this one number 1, this one number 2. M1 is 0.06006. M2 is 0.0060. We got a velocity that's 3 meters per second. Is that 3 meters per second? Is that positive or is that negative? Now, is that positive or is that negative? Good. It's positive because it's north, right? Is that positive 3? Is that V1 or is that V2? Am I V1 or V2? V1. And now, Ty, is that V1 initial or is that V1 final? Good. Now we got another velocity that is, what, 2 meters per second? My 2 meters per second, Emmer, is that negative or positive? How come? Good. Is that V1 equals negative 2? Or is that V2 is equal to negative 2? Michael? V2, good. Is that V2I or is that V2F? Good. Good. Oh, it just keeps going though. All these subscripts. We get another velocity. 1 meter per second. This 1 meter per second, is this positive or negative? Negative, because it's to the south, good. Is that V1 or is that V2? Iana, is this 1 meter per second object number 1 or object number 2? Number 1, good. V1, now is that initial or final? V1I or V1F? Who haven't I called on? Evan? Initial or final? First ball moves at 1 meters per second south immediately after the collision. That's going to be good. V1 final. And we're looking for V2 final here, right? We're looking for how fast is this second car moving after the collision. Now, you could analyze object number 1 using impulse, or you can analyze object number 2 using impulse. But when you have a collision like this, the first thing that I want you to try is conservation of momentum, which means you have to analyze the system, all of the objects. So we're going to say PI is equal to PF. How many objects do we have, Emily, before the collision takes place? 2. So we're going to say M1 V1I plus M2 V2I. Good. How many objects do we have after the collision takes place? First ball moves off at 1 meter per second to the south. What's the velocity of the second car? They could stick together, but they don't tell me that they stick together, right? So we have to assume that they do not. So if they do not stick together, let's make it 2 terms. Let's say M1 V1F plus M2 V2F. If they did happen to stick together, we said that they didn't, and we solved for V2F, what do you think we'd get? -1, right? If they stuck together, we'd solve for V2F and it would be -1. So it's okay if we make them separate like this. Pretty sure they're not going to have stuck together. We're going to get a different number here. But if I'm wrong on that, that's okay. It'll still work out. We'll just get -1 for our answer. Now, I like it when we get a question like this where there's a shortcut. Doesn't happen often, but every once in a while we do. What's the shortcut that we can employ on this one that we couldn't on any of the other questions that we've had so far here? Mason? Yes, you can cancel at the masses, not because there's 2 masses on each term, or on each side, not because there's an M1 on both sides and an M2 on both sides, but rather it's because, yes, 0.006 appears in every term. If they're going to cancel, it's because, not because 0.006 appears on both sides, but because 0.006 appears on both sides in every term. Well, that's awkward.
For once, the tables have turned.
V1I is 3.0 meters per second. Plus V2I, we're not putting M's in there, right? V1I is 3.0 meters per second. V2I is negative 2.0 meters per second. V1F is negative 1 plus V2F. Now, if you didn't notice to cancel out the mass, is that okay?
Yeah.
Sure it is. It's just more math, right? Still get the same answer. Now, the more math you do, the more chance you have of making a mistake. But if you do the math correct, you're still going to get the correct answer. 3 plus negative 2 is negative 1. Negative 1 on the right-hand side. Take, no, it isn't. It's not negative 1. It's positive 1. Take the negative 1 over by turning it to positive 1, adding, becomes 2.0 meters per second is equal to V2F. That's it.